This industrial safety analysis highlights critical failures during a cargo discharge incident. The root cause was improper loading without tension straps, causing goods to shift and create dangerous lateral pressure against the rear doors. As the worker stood in the line of fire directly behind the center of the trailer, the stored energy was released, forcing the doors open with extreme velocity and pinning the individual under the falling load. To prevent such accidents, operators must always utilize cargo nets and follow the side shield rule by standing to the side when unlatching. Assessing latch tension is a vital preliminary step to gauge load stability. Ultimately, maintaining situational awareness and wearing proper PPE, such as hard hats and steel-toed boots, are essential for workplace safety and preventing catastrophic kinetic impacts during logistics operations. This industrial safety analysis underscores the necessity of machine guarding and situational awareness. The incident was caused by a line of fire violation where a worker entered a high-risk crush zone. Technical failures, such as inadequate physical shielding and the absence of interlocked sensors, allowed the machinery to continue its cycle despite the obstruction. Human factors, including the normalization of risk and a lapse in situational awareness, further contributed to the entrapment. To prevent such accidents, facilities must implement strict lockout-tagout LOTO protocols and ensure all equipment is outfitted with accessible emergency stops. Training personnel to recognize red zones and maintain safe distances is vital, as machine torque far exceeds human reflexive capabilities. Maintaining rigorous operational boundaries remains the most effective defense against mechanical hazards. This industrial incident underscores the critical necessity of adhering to OSHA safety standards. The primary technical cause involves hazardous pinch points created by rotating shafts that use high torque to pull in loose clothing or hair instantly. The lack of proper machine guarding allowed the operator to enter a danger zone where human strength cannot counteract mechanical force. Human factors such as improper attire and reduced situational awareness further escalated the risk. To prevent such events, facilities must prioritize safety by design using laser sensors, enforce strict dress codes, and ensure stop buttons are always accessible. Ultimately, this serves as a reminder that machinery lacks judgment and will not stop unless safety systems or human intervention force it to do so. This industrial safety analysis highlights critical mechanical and procedural failures during a forklift operation. The incident was caused by a red zone breach where a worker was positioned directly within the full path of a heavy cylindrical load. The sudden release of the cargo indicates a failure in the rigging system or an uncentered load, creating a high-impact force that overwhelmed the area. To prevent such accidents, facilities must enforce strict no-go zones around active machinery and ensure clear communication between operators and spotters. Mandatory pre-operational inspections and lockout-tagout protocols are essential for identifying metal fatigue. Ultimately, personnel must maintain a safe distance and never walk beneath a suspended load, as situational awareness is the final defense against mechanical failure and severe workplace incidents. This industrial safety analysis serves as a critical warning regarding the hidden hazards of excavation and drilling. Most utility strikes occur when a drill bit makes contact with a pressurized gas line or high-voltage cable, causing ignition through friction or electrical arcing. In some cases, drilling breaches subterranean methane pockets, releasing immense pressure. Because these explosions occur in confined spaces, the force is channeled upward, ejecting debris at extreme velocities and compromising soil integrity. To prevent such incidents, organizations must adhere to safe digging protocols, including calling 8011 for utility marking and utilizing ground-penetrating radar GPRA. Techniques like pothling should be used to safely expose lines before using heavy machinery. Maintaining clearance zones and having emergency response plans are vital for operational safety. The following root cause analysis examines a pressure vessel explosion in a waste collection vehicle, highlighting the mechanical risks of improper disposal. The primary cause is mechanical overpressurization. When high-powered hydraulic compactors crush a pressurized cylinder, internal pressure exceeds structural limits, causing a violent physical rupture. This is compounded by hazardous waste misclassification, where cylinders are hidden within general refuse. During the missile effect, metal fragments and debris are ejected at high velocities, creating a dangerous shockwave. To mitigate these risks, all vessels must undergo professional degassing and decommissioning before disposal. Furthermore, sanitation personnel require visual inspection training to identify cylindrical hazards and must maintain a safe operating zone out of the line of fire during compaction cycles. Public education on prohibited compactor items is vital to ensure occupational safety and prevent catastrophic equipment failure. This incident analysis examines the causal factors of a low-speed vehicle collision, highlighting the critical importance of situational awareness. The primary driver error was the failure to clear the blind spot directly in front of the vehicle before accelerating. Potential distractions likely hindered the driver's ability to notice the worker, while a delayed response time exacerbated the situation. On the worker's side, blind spot entrapment and a false sense of security near a stationary vehicle created a high-risk scenario. To prevent future incidents, drivers should perform a 360-degree walk around and utilize safety tech, while workers must prioritize the see and be seen principle. Ultimately, safety relies on understanding vehicle limitations, using high-visibility gear, and maintaining constant vigilance to avoid the heavy costs of operator oversight. This industrial safety analysis underscores the catastrophic risks of improper scaffolding assembly. Structural instability often stems from missing cross-bracing, leading to a lateral collapse or domino effect. Furthermore, inadequate tie-ins to the building and unstable footing on improper sole boards can cause the entire system to detach or tilt. Technically, exceeding the working load limit through overloading deforms vertical standards, while high winds on debris netting create dangerous sail-like forces. To prevent such incidents, facilities must employ a green tag inspection system and ensure base plates are used on level ground. Personnel must wear harnesses anchored to independent lifelines rather than the scaffold itself. Ultimately, fostering a build to protect culture and rigorous hazard recognition training are the final lines of defense in ensuring safety at heights. This technical analysis examines the mechanical and environmental factors leading to forklift instability during high lift operations. A primary risk is exceeding the load center, where oversized loads shift the center of gravity forward, causing forward tip-overs when elevated. Even slight inclines or sudden mast movements create a leverage effect that destabilizes the vehicle. Furthermore, inertia from rapid braking or lifting can cause loads to slide or pull the truck over. Environmental hazards like uneven terrain and poor pallet integrity further contribute to dangerous dynamic loads. To prevent accidents, operators must maintain the stability triangle, travel with loads low and tilted back, and strictly follow the load capacity chart. Facility managers must also enforce exclusion zones and ensure hydraulic maintenance. Ultimately, safety requires understanding the laws of physics and maintaining strict on-site supervision. This industrial safety analysis examines the risks of high-pressure storage and pneumatic conveying systems. A silo breach often results from system overpressurization caused by seized relief valves or mechanical erosion due to abrasive cement powder. When structural integrity fails, compressed air expands instantaneously, ejecting tons of micro-sized particles that create a total whiteout effect, causing immediate disorientation. To prevent such failures, Facilities must implement non-destructive testing meant to monitor wall thickness and maintain relief system integrity through regular cleaning. Smart interlock systems should be installed to shut down compressors during pressure spikes. Furthermore, personnel must utilize certified respiratory protection and undergo egress training for zero visibility conditions. A proactive safety culture is essential to mitigate these hazards. This technical safety analysis examines lithium-ion battery thermal failure, specifically the phenomenon known as thermal runaway. This self-sustaining chain reaction occurs when internal heat caused by short circuits or overcharging creates an uncontrollable feedback loop, leading to rupture or jetting flames. The thick smoke observed is a byproduct of combusting chemical compounds, which are highly toxic. In the workplace, managing this risk requires charging devices on cool, hard surfaces like desks to allow heat dissipation, rather than on combustible materials. Key warning signs include excessive heat, physical swelling, or unusual hissing sounds. In the event of an incident, immediate evacuation is critical to avoid toxic fumes. Never use water on a battery fire. Instead, utilize a Class D dry powder extinguisher and prioritize personal safety over personal items.